This is Concept T classes, and today we'll deal with Chapter 2 of Class 9 NCERT Science, Is Matter Around Us Pure? So we will be covering this chapter in two parts. So in this video, we'll see part 1. So here we'll see what is a mixture, the different types of mixture, then we'll see what is a solution, suspension, colloidal solution. So that's what we're going to see in this video. The rest of the topic we'll discuss in part 2. You might have noticed the term pure in many of the substances that we buy from a supermarket. Say for example, pure ghee, pure milk, pure oil. So what does this term pure means? According to a common person, the term pure means having no adulteration. No adulteration means no impurities. Some examples of pure substances are pure water, salt, sulfur, diamond. So all these are pure substances. They have no impurities in them. But according to science, a substance is said to be pure only if it consists of a single type of particles. That is, all the particles of that substance are same in their chemical nature. Say for example, a drop of water, it consists of many particles and all the particles should have H2O. See, they should be same in their chemical nature. Okay, a substance is said to be pure only if all the constituent particles of that substance are same in their chemical nature. We'll study more about this molecules, atoms, all in chapter 4. Just now we have to understand that these particles should be same in their chemical nature. Only then that substance is termed as a pure substance. Now in other words, a substance is a single pure form of matter. Now all those substances that have more than one particle are called as mixtures, and according to scientists, all the things are mixtures of different substances. Say for example, milk. Milk is not a pure substance. Why? Because it consists of a mixture of water, fat, proteins, etc. So most of the matter around us, it exists as a mixture of two or more pure components. Say for example, seawater, minerals, soil. So these all are examples of mixtures. So let's understand more about mixtures in the following slides. So what is a mixture? So what is a mixture? A mixture is a substance which consists of more than one kind of pure form of matter mixed in any ratio and not chemically combined together. Say for example, air. Air is a mixture of gases like oxygen, carbon dioxide, nitrogen, argon, etc. So here these gases are mixed in any ratio and they are not chemically combined as well. Therefore, we can say that air is a mixture of gases. Similarly, when sugar is mixed with water, it is called as a mixture. The sugar crystal itself is actually a pure substance, but when it is mixed with water, it is a mixture. So here, what all are the components of the mixture? We have sugar as well as water molecules. But whereas soft drinks and soil, they are not single pure substances. Why? Because in soft drinks, we have a mixture of water, sweetener, fruit punch, alcohol, etc. Similarly, soil also, it consists of many substances. So these are not single pure substances. Therefore, in short, we can say that a mixture contains more than one pure substances. Now, how can we separate these components of a mixture? We can separate it through different types of physical methods like evaporation, sublimation, metallic separation, etc. Say for example, dissolved sodium chloride. That is, when sodium chloride is mixed with water, we get the solution of dissolved sodium chloride. So here we can separate the sodium chloride from water by the physical process of evaporation. Here see, through evaporation. We'll study more about this in the next part. Okay. However, sodium chloride itself is a pure substance and we cannot separate it through physical process. So depending on the nature of the components that form a mixture, we can have different types of mixtures. So let us understand this through a simple activity. Let us take 4 beakers A, B, C and D. Now in beaker A, we have 50 ml of water and we add 1 full spoon of copper sulfate powder. In beaker B, we have 50 ml of water and add 2 full spoons of copper sulfate powder. Now first let's consider these two beakers. What can we see? Both beakers A and B have obtained a mixture which have uniform composition. So these mixtures which have a uniform composition are called as homogeneous mixtures or homogeneous solutions. Now, though both these beakers have copper sulfate solution, the color is quite different. Now, why is that? It is because of the variable composition. We'll understand why this color difference is there in the following slides when we study solution. Okay, so now we just have to understand that this homogeneous mixture can have variable composition. Now let's take the beaker C and D. Now in beaker C and D, let's add some amount of sand in 50 ml of water and some amount of oil in 50 ml of water. What can we see? Beaker C and D, they have obtained mixtures which contain physically distinct parts. See, we can see the parts and they have non-uniform composition. So such mixtures are called as heterogeneous mixtures. So what is homogeneous mixtures? Those mixtures which have a uniform composition throughout are called as homogeneous mixtures. For example, salt dissolved in water, sugar dissolved in water, or a mixture of copper sulfate and water. So all these mixtures, they have uniform composition. And heterogeneous mixtures are those mixtures in which a composition is not uniform throughout the mixture. For example, mixtures of sodium chloride and iron fillings, salt and sulfur, oil and water, sand and water, mud and water. So in all these mixtures, they have non-uniform composition and we can physically see the distinct parts. Now, heterogeneous mixture consists of two or more phases. So when we say that the homogeneous mixtures have uniform composition, heterogeneous mixtures do not have uniform composition, what does it mean? It means that in uniform composition, all the particles or the molecules of these components, they are arranged uniformly. See, there is a uniform arrangement, whereas in heterogeneous mixtures, they are non-uniform. Okay, so that is the meaning of uniform composition and non-uniform composition. Now let's understand more about the types of homogeneous and heterogeneous mixtures. So in order to understand that, let's consider another activity. Take 4 beakers A, B, C and D. Distribute the following samples into each of these beakers. The first beaker, add a few crystals of copper sulfate. Second beaker B, add some spatula full of copper sulfate powder to the beaker. In beaker C, add some chalk powder or wheat flour, and in beaker D, add a few drops of milk and add given sample in water and stir them properly. Now if you observe these 4 beakers, what can we see? Are the particles in the mixture visible? If we direct a beam of light, can you see the path of that beam of light? If we leave the mixture as such, do the mixture be stable or do the particles settle down? And if they filter the mixture through a filtration apparatus like this using a filter paper, are we able to see any residue on the filter paper? What can we see? We can see that in beaker A and B, that is, here we added copper crystals and here we added a powder full of copper sulfate, we have obtained a solution. Now in beaker C, which we added a chalk powder, here we have received a suspension, and in beaker D, which we have added milk, we have got a colloidal solution. So let's see more about the solution, suspension and colloidal solution in the following slides. Now what is a solution? A solution is a homogeneous mixture of 2 or more substances. A solution is a homogeneous mixture of 2 or more substances. For example, lemonade, soda water, these are the examples of solutions. Now usually we consider a solution as a liquid that contains either a solid, like when we dissolve sugar in water, we say that it is a sugar solution. Similarly, if we add gas like carbon dioxide in water, we get carbonated water or soda water. So usually we consider a solution as liquid. But there are solid solutions like alloys. So a uniform mixture of substance in solid form is called as solid solutions, or we have gaseous solutions as well. For example, air. Here the gases get dissolved in gases under given temperature. So we not only have liquid solutions, we have solid solutions and gaseous solutions. Now in a solution, there is a homogeneity at a particle level. Now, what do you mean by the term homogeneity? It means that they are all of the same kind. All the particles are the same. For example, in the lemonade, it tastes the same throughout. That is, here the particles of sugar or salt are evenly distributed in the solution. So, there is a homogeneity at the particle level as well. Now, a solution has a solvent and a solute as its components. That is, a solution consists of two components, a solvent and a solute. Now, what is a solvent? The component of the solution that dissolves the other component in it is called as a solvent, and the solvent usually is present in the larger amount. And the component of the solution that is dissolved in the solvent is called a solute, and it is usually present in lesser quantity. So a solution is made by dissolving a solute in a solvent. Now let's see some examples of solution. A solution of sugar in water. So it is a solution where a solid is dissolved in liquid. So here, which is the solute? The sugar or salt is the solute, water is the solvent, and when we dissolve the solute in the solvent, we get a sugar solution. Another example is a solution of iodine in alcohol. It's known as a tincture of iodine as well. Here, which is the solute? Iodine is the solute, which is present in lesser quantity. Alcohol is the solvent. So here what happens? When we dissolve iodine in alcohol, we get a tincture of iodine. Similarly, aerated drinks like soda water, etc., they are a gas in liquid solution. So here the carbon dioxide gas acts as the solute and the water acts as the solvent. And when we dissolve carbon dioxide in water, we get aerated drinks like soda water or carbonated water. Similarly, air. It is a mixture of gas in gas. So here air is a homogeneous mixture. It consists of a large number of gases. It has two main constituents, which is oxygen, which is 21%, and nitrogen, which is 78%. So here we can see that air is dissolved in, like other gases are dissolved in nitrogen gas. So this is also a gaseous solution. Now let's see the properties of a solution. A solution is a homogeneous mixture. That is, all the particles are of the same kind and they are uniformly arranged. Now, the particles of the solution are smaller than 1 nanometer in diameter, hence we cannot see them through our naked eyes. Now, because of the very small particle size, they do not scatter a beam of light passing through the solution. Hence, the path of light is not visible in a solution. Why is that? It is because of the very small particle size. Now the solute particles, they cannot be separated from a mixture by the process of filtration, and the solute particles, they do not settle down as well when they are left undisturbed. Hence we can say that a solution is stable. So these all are the properties of a solution. Now let's see the concentration of the solution. We observe that in a solution, the relative proportion of the solute and the solvent can be varied. Do you remember the activity where we added about 1 full spoon of copper sulfate powder into 50 ml of water in a beaker, and here we added 2 full spoons of copper sulfate powder into this 50 ml of beaker. So what did we obtain? We obtained a homogeneous mixture, but there was a difference in the color intensity, right? Here we can see it's much more darker. So this solution is termed as a concentrated solution, and this is a diluted solution. So depending upon the amount of solute, so what was the solute in the previous example? It was a copper sulfate. So depending upon the amount of solute present in a solution, it can be either dilute, concentrated, or saturated solution. So let's understand more about this through another activity. Take approximately 50 ml of water each in 2 separate beakers. Add salt in one beaker and add sugar or barium chloride in another beaker. Stir the contents in both the beakers. When no more solute can be dissolved, heat the contents of the beaker to raise the temperature by about 5 degrees Celsius. Now start adding the solute again. What can be seen is the amount of salt and sugar that can be dissolved in water at the given temperature the same. what can be observed from this experiment? We can see that as soon as we increase the temperature, the solubility, that is, we are able to dissolve both the salt and the sugar easily. And we can see that the sugar dissolves in water much more faster as compared to that of salt. So at any particular temperature, a solution that has dissolved as much as solute as it is capable of dissolving is said to be a saturated solution. That is, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. Here, say for example, about 40 grams of NaCl, if we are trying to dissolve within 100 ml of water, we can see that about 36 grams of NaCl is dissolved in this solution and about 4 grams of NaCl remains undissolved. So this is a saturated solution. That is a solution in which no more solute can be dissolved at a given temperature or without raising the temperature. Now the amount of solute which is present in the saturated solution at a given temperature is called as solubility. The amount of solute present in the saturated solution at a given temperature is called as solubility. Now, if the amount of solute contained in a solution is less than the saturation level, it is called as unsaturated solution. Now, what is the saturation level? It is a maximum amount of solute that can be added. So, if the amount of solute contained in the solution is less than the saturation level, it is called as unsaturated solution. Here, we can see that 30 grams of NaCl, if you try to dissolve it in 100 ml of water, it is fully dissolved. So this is an unsaturated solution, a solution in which more solute can be dissolved without raising a temperature is called as unsaturated solution. Hence, from this activity we can say that different substances in a given solvent have different solubilities at the same temperature. So what were the different substances that we used in the activity? Salt and sugar, which was the solvent in the water. So when we raise the temperature to 5 degrees Celsius, we saw that the sugar dissolves much more faster as compared to the salt. So we can say that different substances in a given solvent have different solubilities. Now the concentration of a solution is the amount of solute present in a given amount of solution. So this amount can be either in mass or volume. So we can define the concentration of the solution as the amount of solute which is present in a given amount of solution. Now we can determine or express the concentration of the solution in 3 ways. The first one is mass by mass percentage of a solution. That is mass of the solute divided by mass of the solution into 100. We can determine the concentration through mass by volume percentage as well. So there we calculate the mass of the solute divided by volume of the solution into 100. And volume by volume percentage of the solution is equal to volume of the solute divided by volume of the solution into 100. An example, a solution contains 40 grams of common salt and 320 grams of water. So here the solute is salt and solvent is water. Calculate the concentration in terms of mass by mass percentage of the solution. So let's see. First we have the mass of the solute, which is 40 grams. Mass of the solvent, which is water, 32 grams. Now how can we find the mass of the solution? By adding these two. Mass of the solute plus mass of the solvent, that is 40 grams plus 320 grams, which is equal to 360 grams. So we got the mass of solution. Now how can we calculate the concentration in terms of mass by mass percentage? That is mass of the solute divided by mass of the solution into 100. So here the mass of the solute is 40 grams divided by 360, which is the mass of the solution, into 100, which is equal to 11.1%. Hence the concentration is 11.1%. Now let's see what is suspension. So suspension is a heterogeneous mixture in which the solute particles, they do not dissolve, but they remain suspended throughout the bulk of the medium, and the particles of the suspension are visible to the naked eye. Say for example, muddy water, the sand particles which are suspended in water, float in water. So in all these cases we can see that they are not homogeneous. They are heterogeneous in nature, and all the solute particles, they are not dissolved completely. They remain suspended throughout the bulk of the medium. So such a system is termed as suspension. Now let's see the properties of suspension. Now suspension is a heterogeneous mixture. Say for example, when the chalk is mixed with water, we can see that the chalk particles are not uniformly arranged, right? They are non-uniform. Hence we can say that suspension is a heterogeneous mixture. Now the particles of the suspension can be seen by the naked eye. When we mix sand with water, we are able to see the sand particles. The particles of the suspension, they scatter a beam of light passing through it, and it makes the path of light visible. Now this is called as a Tyndall effect. We'll understand this in the following slides, okay? So the particles of suspension, they scatter the beam of light and we are able to see the path of the light. The solute particles, they settle down when the suspension is left undisturbed, and hence we can say that the suspension is unstable. And the particles of the suspension can be separated from the mixture by the process of filtration. We'll study more about this filtration in the next part. Now when the particles settle down, the suspension breaks down and it does not scatter light anymore. So these all are the properties of suspension. Now the next type of heterogeneous mixture is colloidal solution. So what is a colloidal solution? A mixture in which one substance is divided into minute particles, and those particles are called as colloidal particles, and these particles are dispersed throughout a second substance is called as a colloidal solution. The particles of the colloid are uniformly spread throughout the solution. Due to the smaller size of the particles, the mixture appears to be homogeneous, but actually a colloidal solution is heterogeneous mixture. For example, milk. Now because of the small size of the colloidal particles, we are not able to see them with our naked eyes. But these particles can easily scatter this beam of visible light, and we are able to see this path of light. So this scattering of a beam of light is called as the Tyndall effect, after the name of the scientist who discovered this effect. The Tyndall effect can be observed when a fine beam of light enters through a room, through a small hole or through a window. So this happens due to the scattering of light by the particles of dust and the smoke in air. Similarly, Tyndall effect can also be observed when the sunlight passes through a canopy of dense forest or through a forest. So here in the forest, the mist contains tiny droplets of water which act as particles of colloid and they disperse in air. So this effect is termed as Tyndall effect. Now let's see the properties of colloid. Now colloid is a heterogeneous mixture. Even though it appears to be homogeneous, it is a heterogeneous mixture. The size of the particles of a colloid is too small to be seen in naked eyes. Now colloids are big enough to scatter a beam of light passing through it and makes its paths visible. So the size of the colloidal particles are not too small as that of the solution, and it is not too large as that of the suspension particles, but they are big enough to scatter the beam of light passing through it, and it makes its paths visible. Now the colloidal particles, they do not settle down when left undisturbed, hence we could say that the colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. We'll study more about this separation technique, centrifugation, in the part 2. Now the colloidal solution have two components, a dispersed phase and a dispersion medium. So first let's see what is a dispersed phase. The solute-like component or the dispersed particles in a colloid form the dispersed phase. So the phase that is scattered or present in the form of colloidal particles are called as dispersed phase, and the component in which the dispersed phase is suspended is known as dispersion medium, or the medium the colloidal particles are distributed is called as the dispersion medium. Say for example, here the oil is the dispersed phase and it is dispersed in the dispersion medium, which is water. Now the colloids are classified according to the state, solid, liquid or gas, dispersing medium and the dispersion phase. So let's see some common examples of colloid. The first one is aerosol. So aerosol is actually a suspension of fine solid or liquid particles in gas, or for example air. Say for example fogs, cloud, mist. So this is actually a colloidal suspension of fine liquid particles in air. And when solid particles are suspended in air, the example is smoke, automobile, exhaust. So such type of colloid is called as aerosol. So aerosol is a suspension of fine solid or liquid particles in gas. Now the next one is foam. Now foam is actually the dispersion of gas particles or bubbles in a continuous liquid medium. Okay, so here example is a shaving cream. Now let's see emulsion. So emulsion, like colloid, it comprises of the dispersion of two immiscible liquids. So what do you mean by immiscible liquids? Those are the liquids that do not mix with each other. So emulsion is the dispersion of two immiscible liquids. An example is a milk or a face cream. Next we have a sol. What is a sol? It is a colloid made up of very small solid particles in a continuous liquid medium. So this is the sol. See, this is the type of colloid. Example is milk of magnesia, mud, etc. Next we have one more foam. We said that foam is actually the dispersion of gas particles in a continuous liquid medium, or it can also be solid medium. So if it is in solid medium, we have examples like foam, rubber, sponge, pumice, etc. Next we have gel. Now gel is actually colloids which are dispersed in liquid medium, continuous liquid medium, but they act or behave like solids. For example, jelly, cheese and butter. So these are also a type of colloidal solution. Next we have solid sol. Now solid sol is a colloidal solution where there is a dispersion of a solid in solid itself, but it's a little bit soft. For example, colored gemstone, milky glass, etc. So if you want to know more about any of these types of colloids, please message me in the comment section. I'll give you a detailed lecture of each of these. So this is just for your common understanding what all are the examples of colloids and what all are the types of colloids. So let's take a quick summary of what all we have studied. We studied that a mixture contains more than one substance mixed in any proportion or any ratio. Mixtures can be separated into pure substances using appropriate separation techniques. Then we studied about a solution. A solution is a homogeneous mixture of two or more substances. Solution consists of a solvent and a solute. Then we studied about the concentration of a solution. It is the amount of solute present per unit volume or per unit mass of the solution. Then we studied that materials that are insoluble in a solvent and have particles that are visible to naked eye, which forms a suspension. We studied that suspension is a heterogeneous mixture. Then we studied about colloidal solution or colloids. They are heterogeneous mixture in which the particle size is too small to be seen with naked eye, but it is big enough to scatter a light. Colloids are also useful in industry and in daily life. The particles are called as dispersed phase, and the medium in which they are distributed is called as dispersion medium. So in part 2, we'll be seeing the rest of the topic, how we separate the components of a mixture, the physical and chemical changes, and what are the types of pure substance. So that's all for part 1. Tune in soon for the next session. Thank you so much. May God bless you all. Take care, stay safe, and bye-bye.